Dear students, hope you are great. Today we are going to take chapter 2, one-dimensional motion, section 2, acceleration. First, we should know the meaning of acceleration. Acceleration measures the rate of change in velocity. So acceleration measure what? Measure rate of change in the velocity. I said it before that velocity has magnitude and direction, whatever, to left, to east, to south, and direction. Also, acceleration has magnitude and direction like velocity, because of acceleration measure the rate of change in velocity. So acceleration and velocity have magnitude and direction. SI basic units used to measure the acceleration is meter per second square. So meter per second square used to measure what? To measure acceleration. The units used to measure acceleration. We have three ways to accelerate. When the object speeding up, so when the object increase in velocity or speed up, the acceleration will increase. When the object slow down, the acceleration will decrease. When the object changing in direction, also acceleration will change in direction. If you want to measure the acceleration, we use this equation as average acceleration equal change in velocity divided by time taken, or time required for change. Change in velocity divided by time. Change in velocity divided by time. Change in velocity, which is equal velocity final minus velocity initial. Velocity initial. Final minus initial. For example, if the car starts to move, so it starts from at velocity 0 meter per second. So velocity initial 0 meter per second, which is V initial, until it reaches speed or velocity 20 meter per second. So final velocity 20 meter per second. During time 2 seconds. During 2 seconds. So the time will be equal 2 seconds. If you want to measure average velocity, equal change in velocity divided the time required for change. Change in velocity, which is V final minus V initial divided by time. So 20 minus 0 divided by 2. So the acceleration equal 10 meter per second square. Watch this video.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour, and then it moves right at 30 kilometers an hour, and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration. It will exist only when there is a change in velocity. But how is acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of a formula, acceleration can be written as change in velocity over the time taken. If the velocity of an object changes from an initial value of u to the final value of v in time t, then the acceleration a can be written as v minus u over t. Say this object is at rest initially at point A. It then travels to the right and attains a velocity of 10 meters per second in 5 seconds. What will be the acceleration here at point B? We can look at the formula to get the answer. The initial velocity u is 0 meters per second as the object is stationary. The final velocity v is 10 meters per second and the time taken t is 5 seconds. Hence the acceleration a will equal 10 meters per second minus 0 meters per second divided by 5 seconds. So this will equal 10 meters per second divided by 5 seconds. 10 divided by 5 is 2. Wait, hold on. What will be the units of acceleration? We should get a hint by looking at this. The units of acceleration will be meters per second, because it's the change in velocity over the time taken. As this is meters per second, we can carry this second to the denominator, and what we will get is meters per second squared. This one is more intuitive, but this one is a bit neater, I would say. So the acceleration in this case will be 2 meters per second squared. And acceleration is also a vector quantity. Here, acceleration and velocity are in the same direction. There are many more important concepts about acceleration which we will cover in the coming videos.
Acceleration has direction and magnitude. Direction like positive or like to the right, which is positive. Train move to the right, which is positive. Left, which is negative. And magnitude. For example, high-speed train leaving a station. Imagine that the train is moving to the right. Move to the what? To the right. So the direction is positive. So that the displacement and the velocity are positive. The velocity increase in magnitude as the train picks up the speed. So the velocity of the train will increase. Therefore, the final velocity will be greater than initial velocity. This train starts from start to leave the station at 0 meter per second, at speed 0 meter per second, and then the velocity of this train increase. So the final velocity 0 meter per second is initial velocity, while the final velocity will increase, be greater than, so the final velocity will be greater than initial velocity. So V final, velocity final minus velocity initial, change in velocity, equal velocity final minus velocity initial, will be in positive. So the acceleration will be also in positive, as the velocity final increase or will be greater than the initial velocity. Another case or another situation: on long trip with no stops, the train may travel for a while at a constant velocity. So this train can, in a long trip, move with a constant velocity, for example 60 meter per second. So it moves at 60 meter per second for a long trip. In this situation, because the velocity is not changed, is constant. So velocity final equal velocity initial, which is, so change in velocity equal 60 minus 60 meter per second, so equal 0. So change in velocity will be equal 0. When the velocity is constant, the acceleration is equal to 0, and also change in velocity equal 0, so acceleration equal 0. Another situation: imagine that the train, still traveling in a positive direction, slows down as it approaches the next station. When the train reach the next station, what happened? The train start to decrease its velocity. In this case, the velocity is still positive, but the initial velocity is larger than final velocity. Initial velocity is larger than final velocity, so change in will be negative. When change in velocity will be negative, the acceleration is negative, as this train starts to stop or to slow down. So final velocity is smaller than initial velocity as the train starts to slow down to reach the next station. So the speed of the train will decrease, so the final velocity will be less than initial velocity. So change in velocity equal V final minus V initial, so the answer final is less than initial velocity, so the answer will be in negative, and the acceleration also will be in negative. Acceleration can be described by plot a graph. The slope and the shape of graph plotting velocity or change in velocity versus time, which is mean. So the slope is acceleration. Describe the object acceleration. When the velocity increase, what happened here? The acceleration will be in positive, as this point is V initial and this point is V final. Final greater than initial, so answer or acceleration will be in positive. When the velocity decrease like this is initial velocity, be greater than final velocity. When the speed or when the velocity decrease, so the final is less than initial, so the acceleration will be in negative. Like example, when the car or when the train starts to stop to reach or approach the station, the next station, so the velocity, final velocity, will be less than initial velocity. When the velocity is constant, there is no acceleration. When the train moved for a long trip as a constant velocity, so initial equal final, initial velocity equal final velocity, so change in velocity is 0 and no acceleration here, no acceleration. Example, when the train leaves the station, its speed is increasing over time, like point A. When the train starts to leave the station, its speed will increase, like A here. When the train moves with a constant velocity, for a long trip, the line on the graph continues to the right, but it is horizontal with a slope equal to 0. This indicates that the train velocity is constant velocity, like point P. Finally, when the train approach the station, its velocity will decrease over time. The graph segment represents this motion slow down to the right. Velocity will decrease, like point C here. As at point C on the graph, this downward slope indicates that the velocity is decreasing, so the here indicate that the velocity decreasing over time. That's it. Thanks for watching.